Global Warming or A New Ice Age revision by Alana. So the first section is on global warming or a new ice age. So global warming, the common myths and misconceptions, the role of the media in influencing public opinion, and like what is the evidence of science and what does it actually show. We are entering a new geographical era called the Anthropocene. Proxies show evidence of changing climate through time. These proxies include ice cores, ocean cores, lake sediments, tree ring records, stalagmites and stalactites, corals and boreholes. These models successfully reproduce temperatures since the 1900s, globally, by land, air and ocean. The reconstruction found that global temperature gradually cooled over the last 1,000 years with a sharp upturn in the 20th century. And here we can see a graph made from proxies. So you can see that it's a gradual cool down here and then there's a sharp upturn. This is also known as the hockey stick curve. The hockey stick curve is a jump in temperature and it was originally released by man in 1998. Other information is that every part of the Earth's climate system has continued warming since 1998, with 2015 shattering temperature records as well as more recent records as well. Summer insolation is currently near minimum, meaning there are no signs of the new ice age. Albedo is the Earth's reflectivity, including, so it kind of goes in a circle of albedo, temperature, ice, and then albedo again, because the ice has quite a high albedo, which means it's got quite a high reflectivity, as can be seen here. So carbon dioxide and climate. 97% of climate experts agree that humans are causing global warming. But there is a proposition of relationship between insolation and carbon dioxide concentrations, which suggest the reasoning for the past 8 glacial cycles and also anticipate future periods of glacial interception. Greenhouse gases. So greenhouse gases are a gas that contribute to greenhouse effect by absorbing infrared radiation. Carbon dioxide and chlorofluorocarbons are examples of greenhouse gases. The Holocene. Even without Anthropocene perturbations or disturbances, the Holocene would be unusually long interglacial. The second series of the Quaternary period following the Pleistocene. Often called the postglacial, it has extended from 11,000 years ago until the present, and has been characterized by interglacial conditions, marked with various climate fluctuations and rapid sea level rise. The term was introduced during the 1860s and means entirely modern. And this is a diagram to show the periods and the eras and the eons of the geological timescale. So an example of melting of ice can be seen in the new shipping lanes in the Arctic to be developed, called the Polar Silk Route, which is extremely important for international trade, but then not so good for the environment. Okay, so feedbacks and amplifiers. Due to the increasing complexity of feedbacks, amplifier mechanisms, and chaos and thresholds and tipping points, it's complicating the climate change science even more. So yeah, amplifying is where it's making it worse, and feedback is what happens when something else happens and then it feeds back into each other. The idea of thresholds and tipping points suggests that there's like a point where everything will just tip, so they will reach a temperature and everything will just collapse. Global warming will cause mass extinctions of species that cannot adapt on short time scales. So global warming in the media. Svante Arrhenius, excuse my pronunciation. So in 1896, the Swedish chemist Svante Arrhenius speculated whether and how carbon dioxide emissions could lead to increases in atmospheric temperature and a greenhouse effect. Is the world getting warmer? Was an article by the Saturday Evening Post in the UK on 1st July 1950. It explored the relationships between atmospheric changes in temperature, shifts in agriculture, and also rising sea levels. In 1957, International Geophysical Year, US science reporter Robert Cowan in 1957 wrote, "Are men changing the Earth's weather?" in the Christian Science Monitor. But then between the 1960s and the 1970s, there was very little media coverage. In the mid-1980s, greater international and domestic climate change policy cohesion occurred, with the formation of UNEP, the United Nations Environmental Programme, and increased media coverage. There was also the UK Prime Minister's Margaret Thatcher's statement, and James Hansen's testified to the US Congress. Both of these statements generated substantial media coverage in 1988, alongside a major heatwave in the summer of 1988 that then caused a drought to hit North America, thus sensitising the public to the notion of global warming, and they were actually started to take notice. The media became an increasingly powerful social, political, cultural, and economical institution of power. So this is a bit more detail than James Hansen's to do. He was a NASA scientist and stated that he was 99% certain that warmer temperatures were caused by the burning of fossil fuels and not solely a result of natural variation. He highlighted the presence of anthropogenic global warming and immediate action that was needed. Margaret Thatcher released a statement about global warming, saying that it was possible that with climate change, we have unwittingly begun a massive experiment with the system of the planet itself. And this is a pie chart to show the coverage of anthropogenic contributions. So it looks at the balanced accounts of global warming and the anthropogenic causes, and then it looks at skepticism, the exclusive coverage on anthropogenic warming, and then anthropogenic contribution is dominant. So post 1990s, there was a group called the Climate Contrarians, who were trying to reframe climate science policy with greater uncertainty and breeding greater public confusion. The Kyoto Climate Summit of 1997 changed attitudes towards the environment and energy consumption and stimulated political action by calling for a reduction in carbon dioxide emissions. However, the USA did not sign this protocol. In 2003, the US Senator James Inhofe, former chair of the Environment and Public Works Committee, called climate change the greatest hoax ever perpetrated on the American people. In 2006, there were also some releases of commercials targeting cities, asserting that carbon dioxide is not a pollutant, and using the slogan of "We call it life." The mass media plays an important role in the construction of environmental issues and problems, as said by Boykoff and Boykoff in 2004. Bennett, 1996, suggests the content expressed in the news controlled by normative orders that individuals, journalists, must be contend with. So they have to contend with political norms, economic norms, journalistic norms, whilst balancing reporting on global warming is difficult and may form informational bias. The media coverage is also influenced by external factors including frontier and expansionary mindsets and skepticism and contrarianism. The media shapes public perception. The media is the main source of information and opinions for millions of people. and it's where most people get their science stories from. These platforms include newspapers, magazines, TV, radio, and the internet. Journalists have to constantly juggle meaningful and accurate and urgent coverage. And of course, the public gains most of its knowledge from here, so it's very important that balanced reporting is there. However, most of the time it's not published into popular discourse. And there has also been many cases of information translation law failures. For example, ClimateGate, which is where a lot of emails were released from the University of East Anglia Climate Research Unit in 2009. This caused quite a lot of uncertainty and climate debate within the media. There was also a mistake in the IPCC 2007 assessment report, which suggested that the glaciers are receding much faster in the Himalayas than any other part of the world. However, the glaciers are not actually retreating at the rate stated in the report. So theories of the mistake concluded that it wasn't from the original source and that there was a mistranslation or a mistypo. So therefore the trustworthiness of the IPCC declined. There was also an issue with the Times Atlas, called AtlasGate, where they mismeasured the amount of ice on Greenland and suggested that it had massively changed since 1999. The publishers apologised for their incorrect Greenland ice statement, however. And here is an image of the differences. Histories and causes of climate change. Here is a diagram showing the geological timescale. So the Holocene was the last 10,000 years and the Quaternary was the last 2.6 million years. Climate has been characterised by glacial interglacial cycles for the last 2.6 billion years during the Quaternary period. Periods of colder and warmer climates in the last 1,000 years have also been seen and known as the Little Ice Age and the Medieval Warm Period. So how do we know about these past climates? We know about them because of ocean cores and ice core records, as well as other proxies. Vladimir Koppen was the first climatologist to try and track global temperatures in 1881. This was followed by Guy Stewart calendar in the 1930s. Weather stations get moved as well, causing inconsistencies due to different microclimates. This can also be seen in the urban bubble, where it's supposed to be slightly higher temperatures than it would be in the surrounding regions due to emissions from the urbanisation. So ice core records. Ice core records are high resolution, and each light and dark branch show up to 1 year of snow accumulation. It contains trapped air bubbles from the past, which can show different climates due to temperature proxies, such as the isotopes of oxygen. And it also records volcanic eruptions through the tephra and ash. Ice cores can be from Vostok, Epica, N-Grip, Grip, and GISP2. Epica holds a 720,000 year record so far, and ice core records from Vostok show 100,000 years of cyclinity. But forcing is too weak to produce climate signals and internal amplifications into the Milankovitch theory. So this shows isotopes of oxygen 16 and 18. So what causes climate change? Climate change is caused by plate tectonics, astronomical forcing, solar forcing, volcanoes, and anthropogenic forcing. So plate tectonics. Locations of the continent's shape and ocean currents are surrounded by plate tectonics. So ice sheets develop only when large land masses are close to the poles. The uplift and plate collision builds mountains, meaning the glaciers and snow, due to the high altitude. There are also feedbacks, and it operates over a very long time scale. Examples can be seen in Pangaea, and the gap of the Theresites and Panama, where it changed the ocean flow and circulation. So here is a diagram. And here is the location of the Panama Gap. So it used to cut through here, but then, yeah, it closed up. Here is the UK, and several other places can be seen as well. So astronomical forcing, also known as the Milankovitch theory. So the smaller deviations in the Earth's orbit are responsible for some of the most persistent and far-reaching changes in climate history. So the main theories are eccentricity, obliquity, and precession. The eccentricity is the shape of the Earth's orbit around the Sun, the obliquity is the Earth's tilt, and precession is the wobble on the Earth's axis. So solar forcing, solar luminosity, and energy flow from the Sun, sunspots, darker, cooler areas, magnetic field effects causes increase in iridescence, more sunspots equal more energy flow from the Sun, and Schwabe cycles, which are 11 years. So the Mond Amendment between 1645 and 1715 showed the absence of sunspots reduced solar output, and this linked to the Little Ice Age. Volcanoes and climate. So ash clouds reflect the heat back to the atmosphere. This causes immense feedback mechanisms and actually causes global cooling. Yeah. So global warming, myths and misconceptions. So climate skepticism is where there are myths about how anthropogenic change and influence on global warming is not actually as bad as it's made out to be. However, this is not actually the case. So arguments fall into two types, but technically three. So there is disputing that there is global warming trend, disputing that the global warming trend is caused by human activity, and then there is the pure rubbish. So global warming is an global average, and therefore it is true in some parts of the world, but then some parts of the world it's not true because some parts have actually cooled. Facts. So 2017 was the hottest year on record without the El Nino effect. 2014 was the hottest year before that without the El Nino effect. And 2015 was the hottest year with El Nino effect. So the global average temperature has increased by 0.8 degrees since the 1880s. And 2/3 of that warming has occurred since 1975. And this corresponds with industrialization. So 15 of the top 16 warmest years have occurred since 2000. Forcing factors include insulation, greenhouse gases, aerosols, and amplifiers. Sea level change. Facts. So global coastline estimated at over 500,000 kilometers in length. However, this depends on how much detail you go into along the coast, because obviously there's many nooks and crannies which you could also measure. 50% of the world's population live within 2 kilometers of the coastline due to the dominance of coastal cities in trade and transportation. And vulnerable environments are created due to sea level rise, saline intrusion, coastal erosion, flooding, and hurricanes. Global sea level rise, however, does not exist. It's local sea level rise. Causation of sea level change includes the melting and accumulation of continental ice sheets, temperature causing thermal expansion. Eustasy and isostasy is about, so eustasy is the ice volume equivalent to ice melting into the water. So it's where the ice makes the water rise, whereas isostasy is about the change in the land level. So isostatic uplift occurs when ice melts from the land and then the land rises because the pressure is removed. And here is the predicted IPCC report in the case that if all the ice melted away, what would happen in terms of the predictions are uncertain, but thermal expansion is likely to highly temporarily and spatially variable and will affect sea level. There is also uneven distribution of meltwater and ice melt. Also, general predictions do not help planners for a local area, so it's very difficult to adapt. If the Greenland and Antarctic ice sheets were to melt, the sea level would rise by 84 meters. But it's interesting because where I live, it will be fine. So glaciers and ice sheets. Mass balance is where the accumulation and ablation is subtracted from each other. So the net mass gain is called the accumulation area, and the net mass loss is called the ablation area. The accumulation area is formed from snowfall, blown snow, avalanche snow, condensation onto ice, and snow surfaces. The ablation area, however, is formed by ice melting, iceberg calving, blown snow, avalanche snow, sublimation of the ice. This is a diagram of the glaciers, and you can see the zone of ablation versus the zone of accumulation, and then the actual whole figure of the glacier itself. So the equilibrium line of altitude, also known as the ELA, separates the zone of accumulation versus the zone of ablation. And it is where the balance should be at exactly 0. So mass balance and climate change. So the warming and drying increases the ELA. Reducing the accumulation area and increasing the ablation area shifts the mass balance and negatively affects the glacier and causes glacial retreat. Global distribution of ice masses closely reflects the climate, particularly in temperature and precipitation. At any given point on the Earth's surface, these factors vary, so through time, whether it's short-term and long-term, and then with elevation. These drive glacier mass balance and underline why glaciers are so sensitive to indicators of climate change. So the last glacial maximum was approximately 21,000 years ago. The British Iris ice sheet has been reconstructed from looking at moraines and drumlins, and it is assumed to have approximately 230 glaciers involved within the ice sheet. The Little Ice Age took place between the 1400s and then 1840, and since the Little Ice Age, glaciers have been decreasing on centennial scales, and acceleration in retreat especially occurred since the 1980s. I think that's supposed to say 1780s, sorry. Or not, I don't know. Some glaciers have shown small periods of advances, and some glaciers shrink faster. The Quaternary period is composed of 2 epochs, which are the Pleistocene and the Holocene. It lasted 2.6 million years. And there are 20 transitions from 10% to 30% ice cover. The Quaternary glaciation, also known as the Pleistocene glaciation or the current ice age, is a series of glacial events separated by interglacial events during the Quaternary period from 2.58 MA to present. The interglacial period is long timescales between glacial and interglacial cycles which changes the volume and extent of ice cover related to climate. Changes in glaciers and ice caps provide some of the clearest evidence of climate change. Things other than climate change can cause advance of retreat of glaciers, including calving glaciers, surface debris, surge events, geothermal activity, changing basal stress regimes. Oceans and climate. Facts. So 70% of the Earth's surface is covered in ocean, 96% of ocean is water and the rest is dissolved salts and particles and organic matter and gases. Salinity in the ocean is 35 ppt, parts per thousand. Mean depth of the ocean is 3.80 kilometers. So the ocean's influence upon the climate includes ocean circulation, controlling atmospheric carbon dioxide and absorbing solar radiation. This is an example of the climate system, and you can see in the hydrosphere how the ocean affects the circulation and the climate. Kroll and Milankovitch. So the Milankovitch theory is an explanation of long-term climate change. Milutin Milankovitch built his theory from previous work done by Joseph Adamer and James Kroll. In 1842, Adamer explained glacial climate using only precession. In 1864, Kroll wrote about the orbital change in the ice of the ice ages, using both the eccentricity cycle and the precession cycle. Later, in 1875, he took into account obliquity, tilt of the axis cycle. In the mid-19th century, James Kroll proposed an astronomical theory linking to the Pleistocene ice ages with periodic changes in the Earth's orbit around the Sun. Kroll's idea were later refined and elaborated on by Milankovitch in 1941. The Milankovitch theory is the name given to the astronomical theory of climate variations. Since these ideas were put forward, much evidence has been found to support this theory. Eccentricity. So Earth's orbit around the Sun. The impact of variation is a change in the amount of solar energy from perihelion to aphelion. Obliquity. So the variation of the tilt on the Earth's axis away from the orbital plane. It varies between 22.1 degrees and 24.5 degrees, averaging around 23.5 degrees. The obliquity changes on a cycle, taking approximately 40,000 years. As this tilt changes, the seasons become more exaggerated. Precession. Change in orientation of the Earth's rotational axis, wobble of the Earth's axis and turning around of the elliptical orbit of the Earth. Precession has two components, an axial precession, in which the torque of the other planets exerted on the Earth's equatorial bulge causes the rotation of the axis to gyrate like a spinning top, an elliptical precession in which the elliptical orbit of the Earth itself rotates around one focus. The net effect describes the precession of the equinoxes with a period of 22,000 years. And here are the waves, and usually if they concur and do it together, the effect is exacerbated. So Milankovitch considered the changing seasonal precession and latitudinal obliquity patterns of incoming radiation to be critical in factors of growth on continental ice sheets and in the initiation of ice ages. He hypothesized that the axial tilt was small, large latitudinal temperature gradient. Eccentricity was large and perihelion occurred during the northern hemisphere winter, warming winters and cold summers. Such a configuration would allow the persistence of accumulated snow throughout the months of summer in the northern hemisphere. Additionally, the warmer winters and stronger atmospheric general circulation due to the increased temperature gradient will increase the amount of water vapor at the higher latitudes available for Paleoceanography is the study of geological history of the oceans. It's an interdisciplinary science using multi-proxy approaches to reconstructions. An example of a famous Paleoceanography is Professor Sir Nick Shackleton, who died at the age of 68, was an international scientist of great renown who fundamentally changed our understanding of the Earth's processes of work. His research on ancient oceans and climates have brought both innovative and pioneering, and he identified the precise role of carbon dioxide in the warming and cooling of the Earth's climate. His work contributed greatly to our present understanding of mechanisms of global warming. The ocean currents are driven by the wind density difference. Johannes Sandstrom. In 1908, Johannes Sandstrom laid foundations of our modern understanding of ocean currents, with a series of classic experiments carried out at Borneo Oceanographic Station in Sweden. Sandstrom found the thermal forcings can give rise to steady circulation only if heating occurs at a greater depth than cooling, a fact that is similar to oceanography students as Sandstrom's theory. The thermohaline circulation is where warm saline water flows from the tropic Atlantic region towards the high latitudes, in particular the North Atlantic, due to differential solar heating of the surface of the ocean at high latitudes and low latitudes. At around 60 degrees north, surface water is cooled, subsequently causing an increase in surface water density. The formation of sea ice can also result in brine formation, providing an additional mechanism that creates dense water. This dense water, collectively known as North Atlantic deep water, sinks and flows southward, eventually upwelling in the Pacific Ocean, where it is heated and returned to the North Atlantic as surface water. Antarctic bottom water and lower circumpolar deep water, which are also important sources of deep water in the ocean, are formed. Atlantic meridional to overturning circulation slowdown. A shutdown or slowdown of the thermohaline circulation is an effect of global warming on major ocean circulation. Data from NASA in 2010 suggested that the AMOC had not slowed down, but may have accidentally sped up slightly since 1993. Affected by changes in heat differences between poles and tropics and interjection of fresh water into regions of deep water formations, young dryas, massive outbursts of floods have also affected this. Dansgaard-Otsego cycles. The Dansgaard-Otsego cycles of the last glacial period are now recognized as representing alternation between two climate states with rapid transitions from one state to another. The oceanic pump shows the physical pump and the biological pump of the ocean, which is a lot. So ocean acidification is the ocean absorbs around 22 million tons of anthropogenic carbon dioxide per day, which is about 30% of all anthropogenic carbon dioxide per year. When carbon dioxide is dissolved in seawater, carbonic acid is formed, and ocean water pH is decreasing. Surface ocean acidity increased by 30% over the last 200 years. Effect of placing a tetrapod shell in seawater with pH value projected for 2100. So where is global warming going? As you can see, it's rapidly rising, and most of the global warming is ending up in the sea. So terrestrial records. So the biosphere is affected by the albedo and the reflectivity, because some things are more reflective than others. And there's also an uptake of carbon dioxide and a release of oxygen through photosynthesis, but then vice versa through respiration. And it influences local and regional precipitation, and climate patterns. Here's some more information on the albedo. So feedback mechanisms. So albedo positive feedback. Snow and ice have a high albedo. Evapotranspiration creates cloud cover, which also causes albedo. So proxies. Land use has changed over time due to population, demand for food, loss of biodiversity through clearance. A proxy is an archive of environmental change. It provides indirect measures of past climates. Principle of uniformitarianism. The present is key to the past and the past is key to the future. Using proxies from terrestrial sediment records to create paleo-environmental reconstructions. So peat bogs, partially decomposed plants, low pH and anaerobic conditions. Bogs are often umbrotrophic, so rain-fed, provides clear linkage between climate and vegetation. Detailed records of Holocene climate change and land use change can be found in the peat bogs, and it shows records of temperature change with lower temperatures corresponding to increases in bog surface wetness. Lake sediment records, so natural sediment traps, sediments, grain size and geochemistry, ostracods, sensitive to changes in the water level and salinity, and diatoms are sensitive to changes in the water. Vegetation and climate variability during the last interglacial evidence in the pollen record of Lake Baikal and other lakes. Dendrochronology looks at true ring records. The ring width and density tells us about the temperature and precipitation. So oxygen isotope 18 suggests source water, and then carbon isotope 13 suggests dry sites and soil moisture, and then moist sites as well, and summer temperatures and aridity. Speleotherms, stalagmites and stalactites, have annual bands, so therefore they're multiple proxies, and they preserve quite well and they're quite complex. Precipitates can therefore be analysed. The only issue with proxies data is it's influenced by more than one environmental variable, and resolution can be blurred by natural processes, and they can have gaps and hiatuses. Location of proxies are also spatially limited, and establishing the secure geochronology can be problematic. Multiple proxies replicated records is a must. So like combining ice cores and lake records is very vital to getting correct information. Timescales for some proxies are also quite short and limited, so it's always good to get as many as possible. There's also huge spatial variation, because developed countries have done more research into it than non-developed countries. So permafrost is permanently frozen ground. 25% of the land in the northern hemisphere is made of permafrost, and it's currently thawing and melting rapidly, releasing methane and carbon dioxide, thus making it a positive feedback mechanism because it is actually causing more global warming by releasing more greenhouse gases. Change in the vegetation and geomorphology is also affecting the landscapes, and extreme slumping is occurring, also known as the permafrost megaslumps.